starting right here. Question 1. So this is 2012. And the first question asking about, it says in the real number system, the inverse of addition is represented by, which one represents the inverse? Which one? Yeah, B. All right, so the first one is known as the identity. So any number, when you add, if you have a number x and you add another number to it and you get back the original number, this number that you add is known as the identity. So the identity is 0. Then any number that when you add to the original number, you get the identity, then that number that you add is known as the inverse. So this is the addition inverse of this system. All right. The last one has to do with distributive law. And this has to do with associative law. 0 plus x is equal to x plus 0. This is communicative law and this is distributive law. So B, easy question. Question 2. Question 2, it has that if P and Q are positive integers such that P is less than Q, which of the following is true? To do this question, you can always use actual numbers. So P is less than Q, you can use a number like 2 and 3. So 2 is less than 3, and then when you put the negative of them, you notice that negative 2 is not less than negative 3, but negative 2 is greater than negative 3. And so 1 is true. If you subtract 1 from both sides, you know that 3 is automatically true. And so for this question, you don't see any option with all 3 of them being true, so you don't need to check the second one. So it would be 1 and 3 is true. Go again? Yeah, this question very similar. So sometimes you find that a couple of them repeat. All right, but the only reason why it is very imperative to go through all multiple choice is because with the whole coronavirus situation, there's a great possibility that they might change up the questions this year. Because there's no paper 2 to compensate, they might issue out the second MCQ. So each year, when they prepare CXC, they actually prepare 2 papers. So one is a backup paper just in case something happened. In this case, coronavirus. And so they may be tempted to issue the second paper. They always have a second paper just in case. All right, so the just in case paper, you never know. It might not have any questions repeat, but they're going to be similar to these sort of questions. So it's good to do all the past papers just to be on the safe side. Errol, I can't hear you. You have earphones? Probably you can try your earphones. Hello? Okay. Errol, go again. Yeah, but I'm hearing you very low. I wonder if it's my. Let me see if it's my sound. All right, try do me a favor. Try to you're using laptop, right? Try to turn up the volume on your laptop to maximum. It's already on maximum. All right, let me try earphones and see. Early, can you hear me? All right, I'm hearing you better with the earphones. All right. All right, so we'll go to question 3. And question 3 is asking us, which of the following statement is true? So for question 3, well, first thing I want to say is that, all right, so let's write it down. All right, let's write it down. If I'm adding the sum of some function, I don't know, I'm just going to write f of r. If I'm summing some function of r from r being equal to 1 to n, it's always going to be equal to the sum if I'm adding from 0 to n of the function of r. All right. For example, if you're adding r from 1 to n, if you're adding r from 1 to n, you'd add 1 plus 2 plus 3, and you continue. Now it's going to be equal to the same as if you start from 0. You'd get 0 plus 1 plus 2. The 0 really doesn't change any value. You agree? And so the sum from 0 to n is equal to the sum from 1 to n. That's a very important property that oftentimes we don't write down. There are some other important properties like the sum from 1 to n of a constant k times a function of r. These are easy properties to remember. It is just the constant times the summation from 1 to r. Constant times the summation from 1 to n of f of r. And there's another very important one that goes like this. If we're adding some number from 1 to n, it is the same thing as summing from 1 to, let's say, b of that function of r plus summing from b plus 1 to n of that function of r, and that is going to be equal to the sum from 1 to n. For example, what I want you to think about is if I add from 1 to 3, and then I add 4 and 5, is the same thing as adding from 1 straight 2 to 5. Agree? Yeah, so that's the important property. But the first one is the one that we're being tested off in this particular question. This is the one we're being tested off. So you go back to the question. The sum from 1 to n of r squared is the same as the sum from r being 0 to n of r squared. So that's this one. All right. So that's the property they're testing you off. All right. Now this question is asking us if a remainder, go again. Look at B. Yeah, what about B? No, this is not true. That is never true. The sum from r squared is not going to be equal to the sum from 1 to n of r and then it's squared. So let me look at the example to show you. All right. So the sum from r equal 1. So I'm not going to use n. Let's use n as a number 5 of r squared. What would this be equal to? You put in 1 first, I get 1 squared, which is 1, plus you put in 2 squared, which is 4, plus you put in 3 squared, which is 9, plus you put in 4 squared, which is 16, plus you put in 5 squared, which is 25. So in total, that is going to give us 41, 50, 54, and 1 is 55. So the sum from 1 to 5 of r squared is 55. Now look at this. The sum from r being equal to 1 to 5 of r, and then you square it. You have to work out the sum first and then you square the sum. That would be equal to plug in 1, we get 1, plus we plug in 2, then we plug in 3, then we add 4, then we add 5, and then we square it. 5 plus 4 is 9, plus 3 is 12, plus 2 is 14, plus 1 is 15. 15 squared is 225. You see it now? And so they are not equal. All right, don't look at this as it looks the same because it looks like they just bracket right here. But how I want you to picture this sum is this. Rewrite this as the sum from r equal 1 to r times the sum from r equal 1 of r to the n. When you see the square of the summation, it just means that you're multiplying whatever sum you find from 1 to n of r, you're going to multiply it by the same sum. So it's going to be double the sum. And so that's going to be different from just summing from 1 to n of r squared. But you can always try examples as well. All right? All right, let's look at question 4. And you're fine with the other options, right? You know that those two are A and C are clearly out, right? All right. Question 4. It says if a remainder of 7, where said is it A? Oh, that's a repeat one, right? Yeah, this is a repeat one. So you only check to see if all you do is set f of 3 be equal to 7, then you can solve for k, right? Okay. Question 5 is a repeat one. What's question 5? D? Yes, that's right. That's a repeat one. That's D. It repeated from 2010 that we did last week, and it also repeats from 2011 that you did in the marathon. Errol, you're breaking up. Repeat. Oh, you have it. Yeah. All right, 6 is a repeat one as well. Which one was C? Which one? A. Very good. It's a repeat question again. So you notice how much they repeat. All right, question 7. Question 7 is a formula you pretty much have to remember. A to the n minus b to the n. The difference of 2 power formula. And that formula, easy to remember. A to the n minus b to the n. It starts with a minus b. So it starts with a minus b, bracket. Then you're going to multiply it by a to the n minus 1 times b to the 0. B to the 0 is 1, of course, plus a to the n minus 2, b to the 1. So the powers of a decrease by 1. and the powers of b increase by 1, plus, and you keep on doing that until you have b to the n minus 1. All right? So that's the simple formula that we have to remember. All right? So that formula is a to the n minus b to the n is given by this formula. And the question that they ask us for is a to the 5th power minus b to the 5th power. So it's just going to be a minus b times, put 5 for n, and so it becomes a to the 5 minus 1, which is 4. B to the 0 is 1, plus 5 right here becomes 3 times b, plus a to the n minus 3 becomes a squared, then increase the power of b again. Then we have plus, decrease the power of a, increase the power of b, and then finally a to the 0, which is just 1, and we have b to the n minus 1, which is 4. So we can get rid of this right here. A to the 0 is just 1. That's what we're looking for. That is D. Repeat the formula. B. Oh, B is the answer. Yeah, this is a plus. I'm sorry. Yeah, it should be B. You see how that can be tricky because what I was looking at was inside right here. I thought all of them were A minus B. B is the answer. Very good. Have to be aware of that. So this, I thought both of these were minus. So that's an easy question. All right. Now, the graph now that represents the modulus of x minus 2 plus 1. All right. The first thing I'm going to start off with is, what does the graph of the modulus of x look like? So this is the graph of the modulus of x. So first of all, what does modulus mean? Repeat. All right, so this modulus sign, what the modulus means is that anything that is negative becomes positive. Modulus means length, and length can never be negative. All right, and so what the modulus does is the modulus is a function such that length. So the modulus is a function such that it's equal to minus x when x is less than 0, and it's equal to positive x when x is greater than 0. So pretty much, in other words, what the modulus does, it reflects everything that is below the x-axis over the x-axis. So for example, this is the graph of this is just the graph of x. I'm going to draw the graph of y equal x. The graph of y equal x is this. That's the graph of y equal x, right? Just a straight line passing through the origin. All right, now this part is below the x-axis. What the modulus does, it reflects the part that is below the x-axis over the x-axis. And so now this becomes the modulus of x. So this in black is y equal to the modulus of x. That's the graph of y equal to the modulus of x. So it does reflect what is below the x-axis over the x-axis. And so let's look at the question now. We have the graph of the modulus of x minus 2. So what I would want you to start with is draw the graph of x minus 2 first. So the graph of x minus 2, that's just a straight line passing through negative 2, right? That's just a straight line passing through negative 2. Straight line passing through negative 2. All right. However, the modulus, now the graph of y equal to x minus 2, there is something important I need to show you. We're right here. What happens right here when y is 0, x is going to be equal to 2. You agree with me? So this has to be 2. Yes, so that has to be 2. Now remember, modulus reflects the part that is below the x-axis over the x-axis. And so this part down here becomes like this. That part down there gets reflected over the x-axis. All right, and so instead of passing through negative 2, it's going to pass through positive 2. All right, now one thing I want to tell you now is that this now is the modulus. This is now the graph of y equal to the modulus of x minus 2. However, this was not what the question wanted. The question wanted y equal to the modulus of x minus 2 plus 1. So we need to add 1 to it. Put the 1 in blue, plus 1. So if we add 1 to it, that means we're just going to push up the graph by 1. So therefore, instead of turning right, instead of this point being right here, it's going to be pushed up by 1. Let that point be 1. Yes, so now it's going to pass through 3. It's going to be B, D. What? D as in dog? Oh, C. 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 All right, very good. So that's it. That's how you do those questions. Easy, easy, easy. All right. Now question 9. Question 9 is saying if log to base a of 4 plus log to base x minus log to base a of 7 is equal to 2, then find the value of x. So what we have to do is to solve a log equation. So we're going to solve the log equation. So we have log to base a of 4 plus log to base a of x. Then we have minus log to base a of 7. And that's equal to 2. All right. So the first thing is that we're just going to have to use rules of logarithm that tells us that the log of log a plus log b is equal to log of ab, but then the log of a minus b is going to be equal to the log of a over b. And so to write this together as one log, it's going to be the log to base a of what's going to be positive, this one that are positive going in the numerator, so it's going to be 4 times x divided by 7. And that's equal to 2. You agree with that? All right. And then from that now, there's a rule that goes with log. And so say if this is true, then it implies that a squared is going to be equal to 4x over 7. And so what we can then do is cross multiply the 7 and divide by the 4 to get 7 over 4 a squared. 7 over 4 a squared is equal to x. All right? You agree with this, right? So 7 over 4 a squared is equal to x. That looks like B. All right. All right, question 10. Question 10 tells us that the coordinates of the point P are 4, -3 under a one-way stretch by scale factor 2 in the y direction with x invariant. So the image of P would be,
Oh, sorry, sir. I'm back. My laptop shut off. I'm using my phone now.
okay, that's fine. So what we're doing is we started 2012 paper. All right.
No, it's March. It's me. I came back.
Yes, I know.
Okay. Yeah, number 9 is B, right?
Number 9. Yeah.
Okay.
Number 9 is B. All right. Oh, did you invite your friends?
Oh, yes, but I don't know. They're not. I think they're busy.
Okay. Yeah, whenever they join, they see it. Okay. All right. So now question 10 right here. We're at question 10. Question 10 is saying the coordinates of the point P are 4, -3 under a one-way stretch by scale factor 2 in the y direction with x being invariant. X invariant means unchanged, and it says to find the image of P. So you can always draw a little sketch. It's always good to draw a sketch. So you have some point 4, -3. So when x is positive, that's over here. That's 4. -3 would be down here. So you can put that point like right here and say this is a point P. It says x is unchanged. X is unchanged. That means we're still in this. We're still in this space. And then they said that y is stretched by a scale factor of 2.
Afternoon, sir.
Good afternoon. Good to see you joining. And so if we stretch, if we stretch, if we stretch this point in the, if we stretch this point by a scale factor of 2, all right, and it's only the y value is stretched by a scale factor of 2, we just multiply the y coordinate by 2. And so therefore the image, which is p prime, you can call image p prime is going to be 4, -6, because x remains unchanged. All right. And so that's the image of P, 4, -6. And the image of P is 4, -6 because Y remains unchanged,
Yes,
X remains unchanged. All right? You agree?
Yes, sir.
All right. So that's question 10. Now question 11. Question 11 says, given that the roots of x squared minus 5x plus a is equal to 0, what is the value of a? In order to do this question, you have to remember the, the
What are you
discriminant.
doing? Don't go shouting in the window.
Okay. So x squared minus 5x plus a equals 0. First and foremost, they said the roots are real and it's just real and equal. So there are three possibilities. First thing, if b for any quadratic, if b squared minus 4ac is greater than 0, then we say the roots are real and distinct. Real and distinct. Another word for distinct is different. So real and different. That's the first thing. Real and different. And then if b squared minus 4ac, if b squared minus 4ac is equal to 0, then we state that the roots are real and equal. Real and equal. And then if it's imaginary, then b squared minus 4ac is going to be less than 0. All right? So the case that we want to look at is this case, number 2. All right. So in this case, your a is the coefficient of x squared, your b is the coefficient of x, and your c is the constant. And so b squared minus 4ac is going to be, let's just write out the equation. So we have x squared minus 5x plus a is equal to 0. And so therefore what we have is minus b, which is negative 5 squared, that's your b, minus 5 squared minus 4 times the coefficient of a is going to be 1. Your c is a, and you're solving that equal to 0. Negative 5 squared is going to be 25. So we have 25
minus 4a
is equal to 0. And so if we're solving for a, what are we going to get?
a equals to 4 over 25.
A equals to
4 over 25.
4 over 25, you sure?
If I bring over the negative 4a going to be positive, right?
Yes, so
So
you get
4a
4a
equals,
equals 25.
oh, a will equal to 25 over 4.
A is 25 over 4. So a is 25 over 4. Easy question. So get that a
25 over 4.
25 over 4.
That's greater than 0.
Yeah.
So that means the roots are distinct, real and distinct.
Well, the roots are real and equal in this case because we solved it being equal to 0.
Oh, okay.
So we're looking at this case for when the roots are real and equal. If we were solving for this to be greater than 0, then you'd have gotten that a would have been greater than 25 over 4.
Oh.
All right, so that's what this
Where are
question.
you working?
All right, so that's what this question tested you on. It tested us to remember the
Sir, which year paper is that?
Oh, this is 2012.
So when then they can send us a solution in the in WhatsApp.
Yes, I'll send a solution. Yeah.
Okay.
All right.
Sure, not in that group.
Yeah, I'm going to send the solution in the chat right here in the Zoom chat. All right, just give me a second. So I'm sending the solution in the chat even as we speak right now. (2012). Just let me know if you can see it. It's saying that it's sent. I can see in the Zoom chat. You see the solution in the Zoom chat?
No.
You
I'm
don't
not
see it.
seeing anything.
All right, give it another second. It should be there in just a second. All right, let's continue. If you don't see it in the next 5 minutes, I'll try again. All right. Now this question. Okay, all right. So Errol got it. So I guess it's sent now. And I'm going to send the rest of the solution before class end for the previous years that we did as well. So I'm going to send from 2008 to 2011 very shortly. All right. All right, so I'm sending the other solutions now. They'll be there in like 4 minutes. Just let me know if you see the 2012. You see 2012?
Sir, could you specifically WhatsApp me the solution?
Yeah. Yeah, after class, just private message and I'll send it.
Sir, I'm not seeing anything.
You're not seeing it? So you don't see 2012.
Sir, I just saw the working out, sir. I never saw that. When I downloaded it, I just saw working out, not that.
Oh, you don't see the question paper.
No, sir, just see the working out.
Yeah, that's the work solution. I'm gonna send the paper as well after. I cannot send the paper until I close the document.
And yeah, man, sir, that all right, man. I understand.
Yeah. Okay, yes, Marsh, I will send all the solutions to your email so you can send it in the group to the class as well. All right, so let's get back to it now. Question 12. So question 12 gives us that we have a function f of x, and it's asks when the function is decreasing. Now a function is decreasing when gradient is negative, all right? And so we learned about equations of lines in C-Sec. And we learned that when the line has a downward slope, gradient is negative, and this is when the function is decreasing. This is when f prime of x is less than 0. That's when it is decreasing. A function is increasing when the slope is going upwards. This is when f prime of x
It's
is
greater than
equal
0.
to 0. Yeah. And then it's equal to 0 at a stationary point. So if you have a function and it turns at some point, that's when it's equal to 0. So let's say you have some curve right here. This would be the point when f prime of x is equal to 0. Okay, all right, yes, Colleen, I'll send it to your email as well. All right. All right. So this is just a schematic of what to always use to can tell when a region is going to be decreasing, when a region is increasing, or when a region is stationary. So looking at this question, right here, from the point 3 upwards, the function is increasing, therefore it has a positive gradient. Right here, from this point come straight down to right here, the function is decreasing, all right? And so at this side, the function is decreasing. decreasing. And so the function is decreasing when x is clearly less than 3.
Than 3.
All right, so that's the A.
Yeah, yes, sir. And
That's
if it's increasing, sir, it would be increased in at
Greater
x
than 3. If
an
it
x
was
greater than 3.
when it is stationary.
Stationary.
Yeah, when would it be stationary?
When x equals 3.
Yeah,
x equal 3.
yeah, that's it. That's when it would be stationary. All right, very good. All right, now question 13. Question 13 says an arc may be modeled by the Cartesian equation y equal to minus 2x squared plus 4x plus 1, where x and y represent respectively the horizontal and vertical distances. Find the coordinates of the highest point on the arc. They're asking you for the maximum point. All right, so there are two ways to find maximum point.
You have to differentiate and equal it to 0.
Yes, so that's one way you can do it.
Maximum this when I find d2y by dx squared, right? And if it's greater than 0, it has
Well,
a minimum.
you don't need to use second derivative in this case because you're only going to get one turning point, and they already told us that it's a maximum point, and so you automatically know that the one stationary point that you find is the maximum point. So there's no minimum point. All right. And another way to know that is whenever you have a quadratic and the coefficient of the x squared is negative, then it's a maximum point you're going to have. It's going to be a Frown graph. All right. So let's do it method 1. Method 1 is, first thing you do is find dy by dx. All right. So you find dy by dx and set it equal to 0. That gives you the stationary point. So when we differentiate this, we have minus 4x
Minus 4x plus 4.
plus 4 is equal to 0. Solving this equation, then what's x would have to be?
1.
Negative 4x are equal to 4, so x are equal 1.
X has to be equal to 1. If x is 1,
No.
if x is 1, we can plug back 1 into the original equation, right? So we plug that 1 into the original equation.
Minus 2.
Minus 2 plus 4 plus 1.
Minus 2. 2.
Plus 4, that's 2 plus 1. I'm getting 3.
3.
Yeah, that's 3. Because 1 right here, minus 2, plus 4 plus 1. Yeah, 5 minus 2 is 3. So the highest point is B. The highest point is 1, 3. That's if you're using method 1. Let's look at it method 2 now, which is a traditional method they're expecting you to use, which is completing the square.
Oh.
Method 2. Yeah. The method 2, you know you have minus 2x squared plus 4x plus 1. So the first thing, that's equal to 0. The first thing is we can find the x value at the turning point, xt, and xt is equal to minus b over 2a. So I'm completing the square using the formula method. And so that's going to be equal to
Negative
minus 4 over
2
times 2.
which is negative 1.
And that's, oh, it's negative 2. Remember, 2 times your a is negative.
Excuse me, sir. Only one paper you're doing today?
Well, if we complete 2012 in good amount of time, I want to start 2013 as well.
Okay. And when is the next class?
Next week, Monday, same time, 4 o'clock.
Okay, thanks.
Yeah, so if we continue at this pace, we'll get to finish. We get to finish at, if we do one paper every week, before the exam, we'd stop at 2018. And so at one particular week, we're still going to have to do 2 in order to do every paper before the exam.
Okay.
Okay. So this would be 1. That's the x value at the turning point. And then to get yt now, yt is equal to 4ac minus b squared over 4a. So it's equal to 4 times negative 1 is negative 4 times 1. Wait, 4 times negative 2 is negative 8 times 1, which is negative 8. So I have negative 8 minus b squared, and b in this case is 4, so we have 4 squared, and we're dividing it by 4 times a, which is 4 times negative 2, and 4 times negative 2 is negative 8.
Minus 8.
And so this works out to be minus 8 minus 16, that's minus 24
24,
over negative 8,
which is 3.
which is 3. And so therefore, this thing right here, we can rewrite it in the form. So I'm going to erase this. We can rewrite.
Would it be like x minus h all square
Yes, so it becomes
plus
minus 2 times x minus 1 all square plus 3. That's a completed square. That's when you've completed the square. It looks this way.
Wait, what is the exact format if you're going to put a function in completing the square method?
Repeat.
Like, what is the general formula, or yeah, something like that, sir.
Yeah, the
General
general
formula when you're doing the completing the square method.
So this is it. The general form in which you write a function f of x is equal to a times x plus h squared plus k. All right?
A times x plus h all square
Yeah,
plus
plus
k.
k.
Okay.
That's the general form. All right? So we wrote it in the general form now. And so the highest point is always going to be,
So h should equal to x
h would be
and
equal to negative 1, and your k would be equal to
k
2.
should equal to 3. Okay.
So that's your maximum point, 1, 3.
And our a is negative 2.
Yeah. So if you were to sketch this graph, it looks like this.
It talk about frown, sir.
It has a frown, yeah. And it passed through positive 1, so it looks something like that. And this is the maximum point that they're talking about. 1, 3. All right?
Oh, why couldn't I think of that? I just never remember that, completing the square method.
Yeah, that's all they're asking. They're not they're not really asking you to differentiate or any of that. You could have done it any method you choose. All right.
Okay, the number 15 x as well, sir.
Yes, I will do number 15 like that as well. All right, question 14 is an easy question. They ask the general quadratic equation with roots alpha and beta. So first and foremost, if the roots of a quadratic equation are alpha and beta, it can be in the form x squared minus the sum of the roots
Minus the sum of the roots
plus the product of the two
plus
roots.
the product of the roots.
All right, so that would clearly be b.
B, yes, sir.
X squared minus the sum of the roots, alpha plus beta times x, plus the product of the roots equal to 0. All right. Question 15. Pretty much asking you to complete the square. But instead of completing the square, what I want you to do instead is to just use the formula and find xt, and use the formula to find yt, and that's it. All right? So first and foremost, write it in its standard form, which would be 3x squared minus 4x plus 2. That's the best way to write it. Put it in descending powers. 3x squared minus 4x plus 2. All right. That's equal to. Now they want it to complete the square, so they want you to write it in this form. 3 into x minus the x value at the turning point, 3 minus xt squared plus yt. That's how they want you to write it. All right. And so we find xt, and xt is going to be equal to minus b over 2a, which is minus 4 over 2a, 2 times 3, and 2 times 3 is 6, and 4 over 6 is 2 over 3. There are two ways to find yt. You can use the formula, or you can just plug back in the x value. In this function, it's going to give you the corresponding y value. But let's continue with the formula. So it's 4ac, so it's 4 times 3, which is 2, minus b squared, 4 squared over 4a. So let's put all of that in our calculator. And so what we get is 4 times 3 is 12 times 2 is 24. And so we get 24 minus 16. 24 minus 16 is 2 over 4 times 3 is 12. And 8 over 12 is 2 over 3. 8 over 12 is 2 over 3. And so what we get that is that finally it is just equal to, I'm going to put it in red.
It will be 3 times x, 3 times x plus 2/3 all
X
square.
x minus 2 over 3 square plus,
How's it minus, sir?
because it positive right here. So right here, it's I wasn't writing it in the form x plus h. If I was writing in the form x plus h, the formula for h is b over 2a. H is b over 2a. But xt is minus b over 2a. Is minus b over 2a. That's the difference. All right. So if you write it in the if you write it in this form, then you use the form h is equal to b over 2a. If you write it in this form, 3 into x minus xt all square plus yt, then xt is minus b over 2a.
Minus e.
Yes, over 2a, minus b over 2a. All right, where xt is the x value at the turning point and yt is the y value at the turning point. So looking for 2 over 3 and 2 over 3. That's A. Four times 3, 12, 24, 24 minus 15. Yeah, that's 2 over 3, 2 over 3. That's A. And that completes module 1. So the first 15 questions are going to be module 1. And so now we're on to module 2. Module 2 is going to have 5 questions from trigonometry, 5 questions from vectors and vectors mixed with Cartesian equations, stuff like that. Then you're going to have 5 other questions that are going to be mixed with trigonometry, vectors, or parametric equations.
Circles, sir, circles.
Yeah, circles and parametric equations. So that's module 2. In this case, we said that the center of the circle is the center of the circle is AB. If you have x minus a all squared plus y minus b all squared equal r squared. So the center is 1, 2.
1 and 2, yeah. Yes, sir.
1, 2. All right. Now they give us a trig identity. They want us to simplify this trig identity. All right. So let's do that. So they give us a trig identity. So we have the sine of
So
theta,
that's a cotangent for me now.
cotangent.
Yes, sir.
Let's see.
Uh-huh.
We have the sine of theta times 1 minus sine squared theta over cosine theta times 1 minus cosine squared theta. Well, 1 minus sine squared theta is cos squared theta, and 1 minus cos squared theta is sine squared theta. So we can rewrite this as the sine of theta times, what we're timesing it by is cos squared theta. So
Yes, sir.
by cos squared theta, cos squared theta. And then we're dividing it by 1 minus cos squared is sine squared theta, and we'll multiply by cos theta. All right. Now sine theta over sine squared theta, that's just going to leave 1 over sine theta. Agreed? Times, now the cos squared theta over the cos theta just leaves cos theta. Because cos squared can be written as cos times cos. And so we get cos theta over sine theta, which is cotangent.
All right.
Cotangent theta. Right? Cotangent theta. Yes, Errol, you're right. Cotangent theta.
I mean, he said,
No, Errol said it first, man. He said it. He said it. Yeah. All right. So that's question 17. Question 18. Question 18 says the vector PQ is perpendicular to the vector 3 minus 1. So if they're perpendicular, that means that their dot product is equal to 0.
0. Yes, sir.
Right? And so their dot product is 0. So we can just set the dot product being equal to 0. So that PQ that is 3 minus 1. That dot product is equal to 0. For to solve this, then it's going to be P dot 3 is 3P minus Q equal to 0. So 3P minus Q is equal to 0. Yes, Errol, you're right again. D. That's D. Easy question. All right. Now they said that you have the point P as position vector negative 3, 5, and Q has the point such that PQ is equal to 1, negative 7. The position vector of Q. So first and foremost, what is PQ? PQ is the position vector of the last minus the position vector of the first. So you can always write the vector PQ as PQ is equal to OQ minus
PO plus OQ.
OQ minus OP. That's PQ.
Yes, sir.
All right. And we want to find vector PQ. So I can carry over vector OP over here to get that vector PQ plus the vector OP is going to be equal to vector OQ. So we're just going to add the two vectors.
Wait, we're required to find OQ, right, sir?
Yeah. So add the two vectors to find OQ. So in order to add them, we add the two x coordinates. So minus 3 plus 1 is minus 2, and 5 plus negative 2. And so we're getting negative 2, negative 2. looks like D. All right, D is the answer. Yes, so that's right. That's good. All right. And now we move on to question 20. Whenever you're asked to sketch a graph between a particular interval, so they're asking you to sketch between 0 and 2 pi, what I'd like you to do is complete a table. So this is what I'd like you to do. Always do this. You can never
30
go wrong.
multiplied 60, 90, and 8.
So always do this. Just make a little table. Make a little table and put in your x and y values. So remember, y is equal to a cosine of half x. Y is equal to cosine half x. And you want it between a half of x and they want it between 0 and 2 pi. So what you can do is find values between 0 and 2 pi. So you can use values like 0, 30, 60, and you'll get the idea. You get the idea of what's happening. So you just write down x, and we need values from 0 to 2 pi. 0 to 2 pi. So in between, we can go 30, which is pi by 6. We can go 45, which is pi by 4. And we can skip some value, go 90, 90 pi by 2. So let's observe these values. All right, we'll get an idea of what's happening. So skip out some values. So now when we put in 0, what we're going to get is that the cosine of 0 is 1.
1.
When we put in pi, we put in pi by 6, that would be the cosine of a half times pi by 6, which is pi by 12. The cosine of pi by 12. 180 divided by 12. So the cosine of 15, and that's, and then we know that the cosine of pi by 4,
So cosine of pi by 8.
yeah, cosine of pi by, so tell me these values. First thing, let me just start from 2 pi. If we put 2 pi right here, that's really the cosine of pi, the cosine of 180. What's the cosine of 180? Negative 1. Check it in a calculator. Cosine of 180 is negative 1. So this
Cosine so the cosine of pi by 12.
yeah, so what's cosine of pi by 12?
That is 0.965.
0.965, 97. What's the cosine of, if you put x as pi by 4, we have pi by 8. What's the cosine of pi by 8?
0.924.
0.924. So we catch a pattern, it's decreasing. 0.924, which is 92. What's the cosine of a half pi by 2? So that would be pi by 4. What's the cosine of pi by 4?
That is 0.707, which is root 2 over 2.
707. Very good. All right, and it's continuing. All right, until it reaches negative 1. So notice that when x is 0, it starts from 1,
1.
right? And then it's going down, it's going down, it's going down, it's going down. At some point, it's going to reach 0. But all we know is that when it reaches 2 pi, the value is
Negative 1. So we can look on the graph now, sir.
So this is how it should look. It keep on decreasing and decreasing until it reaches negative 1. So we're looking for a graph that looks like this.
So the answer, boy then.
Boy. Yes, Earl, you're right, boy. Hassan, you said it before, yeah.
Really matter, sir. I
Yes,
learn
that's
same.
right. Yeah, that's the most important thing. All right, this question is so easy, 25. You don't even need to work it out. All right,
Just use the formula, sir.
the formula. So sine of A plus B is sine A
Sine A
cosine B
cosine B plus
plus,
the cosine of A sine of B.
all right, so you heard plus. So automatically these two out. Automatically B and C out. And so it therefore has to be A. Why
Yes,
does it
sir.
have to be A? Because the sine of
Because sine
45,
of 45 is 1 over root 2.
yes, and not a half. Clearly that one is A. So that was very, very simple.
Easy.
Easy, soft, easy
Soft
like
the capital T.
the top capital, soft like Sunday morning, right? Easy
Yes,
like
sir.
easy. All right,
Oh,
now
I need to get this number item 22. I need to get this one in my head again. I forgot how to do this one.
all right, so this question, where the options are labeled, it's very easy. All right. So what I want you to know is first and foremost, for any trig graph, it is between 1 and -1. So look at this. The sine of a function of x is always between 1 and -1. All right, so if I multiply this by 2, if I multiply it by 2, then I get that the sine of f of x, where whatever that function of x for the sine graph is going to be 2.
It's going to be between 2 and -2.
All right, so I'm looking for something with 2 sine something. So the option is going to have to be 2 sine something. The only 2 sine something there is this, 2 sine x. And so it has to be C. That's an easy way to do it. That's an easy way to do it because sine
And if
x
you
is,
look at the multiple, all of these are integral multiples of pi t, you know, sir.
yes,
The x values. So all of them going to be 0.
yeah. And so therefore it is only C. So that's an easy question. Very easy. So yes, Errol, you're right, it's C. So question 23 now, you have a parametric equation and you want to find the Cartesian equation. To go from parametric to Cartesian, we need to use one of the equations and find the parameter. So let's use the parameter t from the first.
So t would equal to x minus 3 over 2, sir.
So x, what's x equal to again?
X minus 3 over 2. So 1
X
over that is going to give 2 over x minus 3.
over x minus 3. So x is 3 plus 2t. X is 3 plus 2t. And what you say was t, Asani?
X minus 3 over 2.
So t is equal to x minus 3 over 2.
I will plug that into y now, because
And you
y
plug
is
into
equal
y,
to 1 over t.
then y, which is equal to 1 over t, then y, which is equal to 1 over t, is going to be equal to 1 over all of that, which works out to be 2
2 over x minus 3.
over x minus 3. Very good. So y is equal to 2 over x minus 3. Right, easy. So question 24. We're given a vector equation as s times -2, 1 plus t times 1, 1 is equal to -5, 1. And you want to find
What I like it.
the values of s and t.
So you're going to do like you're going to set up 2 simultaneous equations.
Simultaneous equations. So well, this is not a 5. This is just my 4 way of writing s. So I struggle with writing s different from 5. T times 1, 1
t times 1, 1. And they said that's equal to negative 5, 1. All right, so s times negative 2, that's negative 2s. And then t times 1 is just t. And for the x part, that's going to be equal to negative 5. So equate our x component and then we equate our y component. We're getting s plus t plus t is equal to 1. So from these two equations, I can subtract them. And I find out that negative 2s minus s, that's negative 3s, is going to be equal to t minus t, that gone. And so I get minus 6. So I'm getting that s is equal to 2. If s is equal to 2, then 2 plus what give me 1? That has to be negative 1. So t has to be negative 1. So s is 2 and t is negative 1. That looks like s is 2, t is negative 1. A. All right, so the answer for 23, just to revise, 23. Well, the answer for 23 was D. Errol, it was D.
Ah.
All right, question 25 now. Question 25 gives us the tan of alpha is 3/4. Now, people, once they give you one trig ratio, you know all the trig ratios because we can draw the triangle. So we can draw the triangle, and once they give you tan, they give you the opposite and the adjacent.
No, 5 o'clock.
So we have the tan of alpha. I'm going to use A for alpha. So the tan of alpha is opposite over the adjacent.
So 3, you're going to put on the other side, the opposite side.
Yeah.
And adjacent, and 4 going to put on the adjacent.
And so the hypotenuse is 5.
Yes, sir. Because that's a 3, 4, 5 triangle.
Yes. And so the next thing we need is the sine of 90 minus alpha. So this is 90 minus alpha. If this is alpha, this is 90 minus alpha. This part is going to be 90 minus alpha.
90 minus alpha.
Well, let's use A since I was using A. That's 90 minus alpha. And so the sine
opposite
of
90 minus alpha is opposite the 4.
Yes.
And the hypotenuse is 5.
Yes.
So it's 4/5.
Yes. So it's always opposite to the angle that you want. Opposite is the one that's opposite to the angle that you want. 4.
Wow, brilliant.
Hypotenuse of 5.
Sir, may I get a trick in a module 2, you know?
Repeat?
May I get a module 2, you know?
No, you get an A in every module. All right. So that's 4/5. You're right. D. You're right as well, Errol. That's D. All right. Now this question, we don't need to work out these ones. Why? Once it's a minus, you know, it can only be 2 options. It has to be the
A
one.
or D.
All right, so let's check it out. Sine 30 is a half times the cos of A. So clearly it has to be A. You don't even need to do anything more. All right, you saw that one clear?
Mm-hmm. And can you use along the formula, Tina, sir?
Yes, so, but instead of working out all of that, writing sine 30 cos A minus cos 30 sine A, well, once you just put in the first value, sine 30, you get the half. And because you know that it has to be followed by a minus sign, it has to be A. So that's the easy way to look at it. So that's 26, A. Now 27. 27,
Yeah,
27 gives us the line through the points P, and P has coordinates K2 and Q has coordinates 6, 8, is parallel to the line with equation 3x plus y minus 21 is equal to 0. So if two lines are parallel, then we know that they have similar gradients. So let's sketch it on a graph what they're talking about. So it's always good to sketch it on a graph what they're talking about. So we have a line, and that line contains P and Q. So this is P, and this is some point Q. I'm just doing a rough sketch. So P is the point K2 and Q is the point 6, 8. K2 and 6, 8. K2 and 6, 8. That's P and Q. This is P and this is Q. And then they told us that it is parallel to some other line that goes like this. This is some other line, and this other line is defined by the equation. This is 3x plus y minus 21 equals 0. So I can write it as y is equal to 21 minus 3x. So we have some equation y is equal to 21 minus 3x. And so pretty much what they're telling us is that the gradient of this line is -3. And so if the gradient of this line is -3 and this line is parallel to this line, then the gradient of PQ is equal to -3. That's what they're telling us. Because this line is parallel to this line, so they have same gradient. Since the gradient of PQ is equal to -3, the gradient of PQ is y2 minus y1. So it is 8 minus 2 over x2 minus x1, which is 6 minus k, and that's equal to -3. Now 8 minus 2 is 6, and so we have 6 over 6 minus k is equal to -3. In order for this to be equal to -3, then 6 minus k must be equal to -2. Think about it. In order for 6 over something to be -3, then the denominator must be -2. And so if I bring over that, what I'm getting is that k must be 8. K is equal to 8. That's k. Agreed? So k is equal to 8.
Agree.
Easy question. So, a capital V. All right. Question 28. Now, question 28 says that the vector u has magnitude 4 root 5 units and is parallel to the unit vector v. A unit vector parallel to u is, so first and foremost, I need to show you how they write unit vector. This is how
A
they
unit
write.
vector has a magnitude of 1 unit, right?
Yes, a unit vector has a magnitude of 1 unit. A unit vector, so I can put this unit vector is equal to 1 over, so the unit vector v is 1 over the norm of the vector v times vector v itself. That's a unit vector. All right? From all the options given here, there are only one unit vector, and it is C. There's only one unit vector given right here. So how do you know that it's a unit vector? You need to just check if, when you work out the magnitude of all of these, you should get 1. All right? This is going to be the only one that's going to give you a magnitude of 1. All right? How do I know that? You can check it. How do you check magnitude of a vector? Just to
The
refresh.
square root of x squared plus y squared, right?
Yes, exactly. So if I give you v is equal to, let's say v is equal to ai plus bj then the magnitude of that vector is a square plus b square,
Plus b square, yeah.
square rooted. That's how you check the magnitude. All right. There's only going to give you one vector right here with a magnitude of 1. All right. And that's the only, because look at this. All of these vectors are actually parallel to you. All of them are parallel to you, right? Because all of them are multiples of you. But the question asks you for a vector that is not only parallel to you, but also a unit vector. Also a unit vector parallel to you. And so that's C.
So C won't work out to give you 1, sir.
Yes, when you check it, so 1 over
Because
the root of
the
5,
square root of 1 plus 2 square plus negative 2 square. So that's the square root of 5 times 1 over root 5. Oh, yes, sir. It's C.
so that's the only one that's going to give you a magnitude of 1. So that's all you needed to do in this question, guys. Check which of these give you a magnitude of 1. Easy question, soft, easy like Sunday morning. All right. Question 29. It says the distance d in meters of an arm of a shaping machine from its position can be modeled by the equation d is equal to 12 cos theta plus 5 sin theta. The maximum distance in meters from the starting point. So there are two ways to do this question. All right. There are two ways to do it. Let's do it the normal way first.
Maximum.
Yes. So the first way to do it is to write it in the r cos or the r sin form.
Yes, sir.
So we have d is equal to 12 cos theta plus 5 sin theta. So we have 12 cos theta plus 5 sin theta. And so if you write it in the r sin form, remember r
Cosine of an
is
angle does not
equal
exceed
to
1, sir.
r is equal to a squared plus b squared all square rooted. Right? That's how you find r. And so this can be written as in the r cos form, it's going to be 12 squared plus 5 squared all square rooted. That's
13.
That's 13. So 12 squared plus 5 squared all square rooted times the cos of theta minus alpha.
So when we use theta minus, that's what I wanted to ask you.
We use theta minus alpha. It stems, I'm going to show you after this. So all of
Yes,
this
sir.
is supposed to be 13 cosine of theta minus alpha. So that's 13 times cosine of theta minus alpha. And now, so I'm going to show you Asani very soon. I just want to do this one last part right here. Now, first and foremost, you know that the cosine of anything, so cos in general is between 1 and negative 1. And so 13 times cos is going to be between 13 and
And
negative
negative
13.
13.
Very good. And so the maximum distance that the function is going to then be is 13. So that's the maximum distance, 30. All right, so let me show you now why it is minus. I'm going to show you why it is minus. All right. Oh, all right, wait. Just let me tell Errol what was 20. 24 Errol was 25, 25 and 26. 26 was A and 27 is C. Just for Errol, he just came back. So 26 Errol is A and 27 is C. All right. Now 29 is C. All right. So as we were saying, Asani, let's go through why it is. Let's show you why it is cost now. It is cost because let's go back to how you expand the cosine of a minus b. How do you expand the cosine of a minus b?
Cosine A, cosine B, plus
Cosine
sine A, sine B.
cosine a cosine b plus sine a sine b. Very good. Sine a sine b. Now, if you were to multiply this by r, let's multiply it by some r. So I'm multiplying it by r.
It's gonna be
Then it's going to be r cos a cos b plus r sine a sine b. Agreed?
yes, sir.
R. Very good. So r cos a cos b is equal to r sine r cos a cos b plus r sine a sine b. All right. Now, let's say this is then equal to, let's say it's equal to, this is equal to a, well, I shouldn't have used a right here. Let's use a different constant. Let's say this is equal to p cosine a. So this trig equation is equal to p cosine a plus q.
I get P from, sir.
P is just a constant. All right, so since I'm using, let's make this easier. Instead of saying a and b, let's use what you're used to seeing right here. You're used to seeing theta.
Theta minus alpha.
Yeah, and so let me write theta. Theta alpha.
So sine alpha, cosine, sine alpha, sine theta.
Yeah, let me use what you're used to. All right, generally, they'll tell you to equate something like a cos
Yes,
theta.
sir. Based upon the equation I didn't give you.
Yeah, so use a cos theta plus b sine theta and write it in this form. So pretty much, they're telling you to equate a cos theta plus b sine theta. This. They're asking you to equate this to this. But the only way you can equate this to this is to use this formula.
Yes, sir.
You have to expand it
So
out.
that means A cosine theta would have equal to
R,
R cosine theta cosine alpha.
very good. So R cosine theta cosine alpha is equal to A cos.
And then in that case, now A would have equal to cosine alpha.
All right, you don't even need to, yeah, A was equal to cosine alpha, but let's just leave it right here. Call this equation 1. And equation 2, we're going to get that R
B
sine theta
sine
sine
theta equal to R sine alpha.
Very good. R sine theta sine alpha is equal to B
B sine theta.
sine theta. Very good. Let's say you wanted to divide the second one by the first one. So, all right, I wrote it in different order, but let's say divide this by this. The R's cancel. I end up with cos theta. All right, so sine alpha. So this cancel. Cos theta over all right. Let me not do it this way. Let me do it this way first. Change the ink. So right here, the cos theta cancel. And so as you were saying, R cos alpha is A. R times the cosine of alpha is A. And if R times the cosine of alpha is A, from the other one, we're going to have R sine theta. It's going to cancel the sine theta here, and we're going to end up with R sine alpha is B. Can you see that? And then, if we have R sine alpha is A and R cos alpha is B, then I can
Square both sides.
I don't need to square both sides. I can write that the cos of alpha is A over R. Cos of alpha is A over R. And then the sine of alpha over R. Agreed? Then you can draw your triangle. And let the angle be alpha. So what they're saying is the cos of alpha is adjacent is A,
Over
hypotenuse,
the hypotenuse.
and then from this we're saying that the opposite is B and hypotenuse is R.
Yes,
And
sir.
so clearly from this A square plus B square, all square rooted is going to be equal to R from Pythagoras theorem. And then clearly from this as well, the tan of alpha is going to be equal to
B over A.
B over A. And that's how they derive it. All right, so this is equal to this if and only if these two conditions are true. All right,
Best to use cosine of theta minus alpha then.
and that's why they use minus. All right, this
So if
equals
I get a question like this, sir, I must use minus instead
minus,
of plus.
yes. So anytime it is A cos theta plus B sin theta, they use minus. But let's say it was plus right here. Let's say it was plus right here, then right here they use minus.
Oh, okay.
All right.
I'll be aware of that little trick.
Yes, so that's a little trick because of the expansion of cosine is unique. All right.
Yes, sir.
Back to what I was saying now, this is method 1 to obtain that that you get 13 as a maximum. But let's do it method 2. Method 2 is using differentiation. All right. So what we can do is they give us the function d. We can find the derivative of d. When you find the derivative of d, you find the value of theta where it turns, and then you plug in that value of theta back into the function to get the maximum point. So we have d, and so when you differentiate, you find d
B by d theta.
d theta going to be equal to differentiate cos, we get minus sine, so we get minus 12 sine theta, and then we differentiate sine, we get cos plus 5 cos theta, and that's equal to 0. If this is equal to 0, what I can then say is minus 12. Now look at this. If I divide through this equation by sine, I get minus, well, if I divide this equation through by cos, not sine, cos. Sine over cos is
tan theta.
so minus 12 tan theta plus 5 equal to 0. And so what I actually find out is that the tan of theta is going to be equal to, that looks like
Negative 5 over 12.
Well, negative 5 over negative 12, and then the negatives cancel.
Oh.
All right, so I get tan theta is equal to 5 over 12, and so theta is tan inverse of 5 over 12. Tan inverse of 5 over 12. And that, if you're using degrees, you're going to get 22.6 degrees. All right, that's what you'll get if you're using degrees. All right, and then after you get the value for theta for which it is maximum, then d max, we write this, d max is equal to 12 cosine 22.6 plus 5 sine 22.6. Now you should get 13.
What if I use radians?
These radian is still the same answer. Just make sure you put your calculator.
0.395.
So try it in radians. Try it in radians.
59.395. Get 13, sir.
Yeah, 13. Very good. And that's going to give you your 13 as well. So you can use differentiation as well as trigonometric formulas.
Okay.
Right? 30. All right. Question 30. Sorry we spent so long on question 29. Question 30. Question 30 gives us the point 23, which is 1/8 the diameter of a circle, x squared plus y squared minus 10x plus 2y. First and foremost, yes, but you did see. So let's just work it through quick and fast. So first thing we can do is actually find the center of the circle. There are two ways we
And then we
can,
can sketch it, sir.
yeah. So how they tell you the quick way to find the center of the circle is divide through the x and the y by -2. And so the center is 5, -1, right? That's a quick way. They tell you to divide these two terms by -2.
-2.
Yeah, that's why that's the shortcut way. They say divide the x term and the y term by -2.
But why -2, sir?
Why -2? That's just the shortcut method. I'm not a fan of the shortcut method. All right. So if you're to do it by the normal way, you complete the square. That's how I like when it's done. Right? The normal way is you complete the square by grouping the x term. Say
You
right.
take half of x, the x coefficient, and half of the x of the y coefficient.
Yeah. Y square, what was that? Plus 2y. 2y
Plus 2y plus 1
plus 1.
equals 0.
As Asani said, you half it, so you get x minus,
X.
so half, then you get 5.
X minus 5 all square.
You subtract 5 square, which is 25, plus half it again, you get y plus 1.
Y plus 1 all square.
And then you subtract back 1, then you add 1 again. And so just to write it in its standard form, it is x minus 5 all square plus y plus 1 all square, and that's equal to 25, because the minus 1 plus 1 is that. And that 25 can be written as 5 square.
Yes, sir.
All right. Now you
So
can.
that means R equals 5.
R is 5. And the easy way, as I was saying, is that you get the center is 5, -1. The shortcut method is you divide through by the x term by -2. That give you -5. You divide the y by -2. And that give you -1. So you get the 5 minus 1 if you just divide it by -2. That's the shortcut method. So in our multiple choice, just do the shortcut method to get the center of the circle. That's a shortcut method. So now they tell us one endpoint of the circle. They told us that one endpoint was 2, 3. So let me write 2, 3 up here.
So 1 point is 2, 1, 3, and the center of the circle is 5 and -1.
5 and -1. Very good. Now look how I want you to do this now. To find the x coordinate right here, right? It go from 2.
So you know you can use like the midpoint, the formula for the midpoint.
Yes, point. But you don't even need to use midpoint.
You can use all the formula for length.
You don't
The
even
length
need
of
the
the
formula for length. Just look at it. You go from 2 to 5. That means you go 3 units across on your x. So that means because we know this distance is going to be equal to this distance, then we must go 3 units across again for each 8. That makes sense?
Yes, sir.
Yeah, so you don't need to use the formula. And then if you go from 3 to -1, right, that means we'll go 4 units down. So we'll go
Yes,
4
sir.
units down, which is subtracting. So then we're going to go 4 units down again, which is -5.
-5.
And so the coordinate of the other
end is
endpoint
8
is
and -5.
-5.
Oh, them look a simple trick there.
Yeah, you don't need to be working out so much. So you see the simple trick is To get the radius, to get the center, or rather, you can divide the x and the y by -2. That's a shortcut method. And then once you get the center, then you could do this little trick to reach over here quickly. When you're doing multiple choice, you want to save time, right? You don't want to be spending too much time working it out. Yes, Errol, that's good. The shortcut method. That's easy to remember. Just divide this x and y term by -2. All right. Let's go to 31.
Oh, that is how you get the normal C1 is divided by -2. Cause you can just pick out the center right there. So
From right there, so yeah. Anytime you divide by -2. Now this question asks us for the first derivative of -1 over x squared minus 1. So
you can rewrite that as -1 times
exactly.
to the -1 pool.
Yes, so rewrite it as minus of x squared minus 1 to the -1.
X squared minus 1.
X squared minus 1? Yeah, x squared minus 1 to the -1. You can rewrite it like this to then differentiate it. You get dy by
Differentiate
dx.
that now. You're gonna bring down the power and then subtract 1 from the power.
You carry down the power. -1 times -1 become +1.
Positive. So
Then
x squared minus 1.
Then you subtract 1 from the power to be x minus
2. So it's going to be 1
differential inside the bracket, which is 2x.
X.
And so then that does work so to be 2x times
over x minus 1 all square.
Yes, over x squared minus 1 all square. Easy question. So, with a capital T. 2x over x squared minus 1 all square. That's B. All right. Now question 32 is also quite easy. It says the function g is defined as g of x is equal to 3x plus 5 times p of x, and then you have p of x plus 2. So it's equal to this when x is less than 3, and it's equal to this when x is greater than or equal to 3. Now find the value of p that makes the function continuous. If the function is continuous, then f of 3 on the left-hand side must be equal to f of 3 on the right-hand side. And so let's put x as 3 right here, and we get 9 plus 5 is 14 is equal to 3p plus 2.
3p plus 2, yes sir.
If 3p plus 2 is equal to 14, then 12 is equal to 3p.
4.
Yeah, and p is equal to 4. That's clear? That's clear? Errol, that's fine? Errol, that's fine? All right, good. So that's C. Easy question. Now this question now is testing our knowledge of limits by first principle. So this question is quite easy, but I just want to write down the formula again. So remember it. Limit by first principle. So the limit as h goes to 0 of f of x plus h minus f of x over h, that is f prime of x. This is f prime of x. This is the first derivative with respect to x. That's limit by first principle. So limit by first principle, we're going to look at f of x plus h, which is, in this case, it is f of r plus h. So it is pi times r plus h all squared minus pi r squared over h. That is A.
Wait, sir. Wait. I'm kind of lost right there now.
All right, give me a
F
second.
of X. F of X is pi r square,
F of
right?
R, F of R.
F of R is pi r square.
Yes.
Then F of R plus H is pi times
So let's write it
R
down.
plus H.
Yeah, so let's write it down. So in this case, we have F of R is equal to pi R square. Pi R
Oh,
square.
so you replace the R with H plus
R,
R.
so you replace
The
it
R
with
plus
R
H, I
plus
mean.
H. So you get pi times,
R plus
pi
H all
times
square.
R plus H all square. So it is pi times R plus H all square, subtract pi R square over H.
Okay, so
That's A. Yeah, that's right as well, Errol. A. That's 33. A.
Errol, go on, good man.
Yep. All right, now this question, easy. The integral from 2 to 5 of 4 over f of x. The first thing you can do is divide both sides by 4. To get the integral from 2 to 5 of f of x is 9 over 4.
So you can pull out the 4 out of the integral since it's a constant.
Yes, exactly. That's what we were
So that's
saying.
4 times the integral of f of x
So
would
4
equal
times the
to
integral
9.
of f of x is 9 over 4, is 9. 4 times, I'm leaving off the dx because it's a multiple choice. And so you can get now the integral of f of x
Is equal to 9 over 4.
9 over 4, very good. Then the question asks you for 3 times the integral of f of x. So it
So
implies
all of
that,
them multiply 9 over 4 times 3.
yes, multiply
I
9
get
over 4 by
27 over
3.
4.
So 3 times the integral of f of x is 27 over 4. Easy question. Soft.
Oh,
Capital T. Soft with a capital T. All right, question 35. I'm sure it's going to be volume. There are two formulas to find for volume. There's something known as volume around the x-axis, and then there's volume around the y-axis. All right, so before we even look at the question, again, I'm just going to write down the formula for volume. All right, so the volume,
pi times the integral from a to b of y squared dy.
volume from A to B of y squared dx. This is volume around the x-axis.
Oh, sorry.
This is volume around the x-axis. Right? So sometimes you see them ask for volume around x-axis, and next time you ask for volume around y-axis. Volume around the y-axis is pi times the integral from A to B of x squared dy.
Okay.
X squared dy. That's volume around the y-axis. All right, so that's why I wrote it down. Very key. So a lot of time they give the same question. Every year they put this question, but every year they change up whether it's x-axis or whether it's y-axis. All right, they like to do that. So if you look at it now, we just need to make y squared the subject. And so y squared is going to be 4 minus x squared. And so you just look for whichever one that y squared is equal to 4 minus x squared, and that is B. Right? So that's that question. Easy. Soft. Easy like Sunday morning. All right. Question 36. Now, in order to do question 36, there's a particular rule that you have to remember, that the sine of x over x, the limit of that when x is going to 0 is 1. So you have to remember this, that the limit as x goes to 0, the limit as x goes to 0 of sine of x over x is
Is
equal to
1
1. And it don't even have to be x, it can be ax over
over
ax
AX.
is 1. And so this question gives us the limit as x goes to 0 of the sine of 3x over x. Now look how you can do this question. You need ax over ax. And so you're going to put a 3 right
Multiply
here.
both sides by 3.
Exactly. So you put a 3 in the
Because you
numerator
want to
and a 3 in
maintain
the
the function.
denominator.
Since you can
Yes.
only introduce 1 when it comes to limit.
Yes. And so right here now, this part, we know that this part is 1.
1,
This works out to be 3 times
3.
1,
3 times 1
which
is
is
3.
3. That's how you do that question.
So that one time.
Easy. Soft. Soft with a capital T.
Capital T.
Right. Question 37, there are 2 ways to do it. Later on, when you're doing Unit 2 next year, everybody, you learn implicit differentiation. That makes it easier. But for now, we'll do regular differentiation using chain rule and product rule and quotient rule. The boring way.
Boring.
So we have y is equal to the square root. Repeat. Go ahead and speak. So we have y is equal to 2x plus 1. Y is equal to 2x plus 1 square rooted. And so this can be written as 2x plus 1 to the half power.
power.
All right, and so then now we get dy by
Bring
dx.
down the half.
Yes, bring down the half.
Rewrite back 2x plus 1. Then multiply it by, no, right by the half. Times 2x plus 1.
Right back the half, you sure about that?
Wait, sir. Subtract 1 from the
Subtract
power.
1, yeah.
And then you multiply by the derivative of 2x plus 1.
Which is 2. Very good.
And that works out to be 1 over the
This
square root
2
of...
cancel this 2.
Yes,
So
sir.
let's just go ahead straight away and find the second derivative. So d2y by
But sir,
dx.
they will finish.
We'll finish. We don't need to flip it over yet because we still differentiate.
Oh, all right.
So let's just bring down this power now to be negative a half times subtract 1 from the power
2x plus 1 to the negative 3 over 2
the negative 3 over 2
times 2.
times 2. Very good. This 2 cancel this 2.
Yes, sir.
So what we end up getting is negative 1 over
the square root
2x plus 1 square root
of 2x plus 1 all cubed.
Cubed. Very good. Now, what I want to show you is this now. All right, this is to the 3 over 2. Anything to the 3 over 2 power, like look at this, a to the 3 over 2 power, I can write it as a to the half plus a to the 1. A to the 3 over 2 is equal to a to the 1 times a to the half. Agreed?
Yes, sir.
And so in the denominator, what I'm trying to say then is that 2x plus 1 to that 3 over 2 power, you can write the denominator as it's going to be equal to 2x plus 1 times the square root. That's 2x plus 1 times the square root of 2x plus 1. So that's how you can write the denominator as well. So that's going to be C. Easy question. All right, that's C. Question 38. Question 38 now, very easy. It says, in the graph showing y squared is equal to x, where is the function not defined?
For x is less than 0.
Yes, when x is less than 0, we have no
It's
y value
undefined.
over here. So
Yeah.
the function is not defined over there. And so the function is not defined when x
X is less than 0.
less than 0. B. Yes, Errol, that's right. B. Very good. All right. That's B. Question 39. To do question 39, what you're going to have to do is to differentiate twice. So in differentiating twice, when
So
you
I think we
differentiate,
get A.
so you differentiate 3x squared twice, you get 6x, then you differentiate 6x, you get 6. When you differentiate sine, you get cos, so you get plus 10. And then when you differentiate 10 cos x, you get minus 20 sine x, so it is A. Very good. So you're just differentiating twice. All right? Now let's look at question 40. We're going to be integrating from 0 to pi by 4.
So if we integrate secant square x, you get tan x.
Very good, yes. So integrating from 0 to pi by 4 of secant square. When you differentiate tan, you get secant square. So when you integrate secant square, you get back tan. So what you get is tan x. You get tan x, and you're integrating tan x from 0 to pi over 4. This should be 0. Now, what is the tan of pi by 4? What's the tan of 45? Tan of 45?
1.
1. What's the tan of 0?
0.
0. And so the answer is just 1. Very good, Errol. B. That's right. That's 1. Right. Now, question 41. Now, look at this. Now, look how them really nice. Them just tell you when you integrate sec square, you get tan. So you differentiate tan, you know, must get back sec square.
Yes, sir.
See how them nice? Then basically I intertwine the two questions right here for you pick up what you must do. So you differentiate tan, you get sec square, but then you times it back by the differential of 6x,
That
which
be
is
6 secant square 6x.
6 secant square 6x, which is C. Nice. Very good. Easy. Soft. Now, finally, we get a different style of integration question. You're being asked to integrate 2 cosine 5x. So we're being asked to integrate from 0 to pi by 2 of 2 cosine 5x. When you integrate cos, what are you going to get?
Sine.
What?
If
When
we
you integrate
integrate
cos?
sine.
Yes, that's right. I just want to see how strong your resolve is. So it's not just sine. For this case, it's 2 sine 5x.
2 sine 5x divided by 5.
Divided by 5. Very good. And we're going from 0 to pi over 2. Pi over 2 is 90 degrees. What's the sine of 90?
1.
And so right here, we're just going to get, if you work it out, the sine of 5 times 90 is still going to be the sine of 90.
That's 5 times 2, which is 10, right?
Yes. And so right here, we get sine of 90 is 1. And 2 times 1 is 2. We'll get 2 over 5 minus, now when you plug in 0, the sine of 0 is what?
0.
0, so you get 0 over 5, which is 0. So the answer is 2 divided by 5, 2/5.
Wait, sir, the sine, sine of pi over 2. Oh, that's one. That's one for you.
Yes, that's what I was saying. Remember, you know, so this 5 right here, this just means that you spin around the circle 5 times. So it's the same value, right? So remember, we looked at this before, Asani. This is what I said. You didn't need to even multiply it by 5, right? I was telling you that let's look at this. You have a circle, right? Let's say this is where you start. So this is a line. This is 0, right? This is angle 0. If you spin around the circle, right? You start from 0, spin around the circle, that make 360 degrees.
Yes, sir.
I'm telling you then that the sine of 0 is going to be equal to the sine of 60. And if you spin around the circle again, you get 720. The sine of 360 is also going to be equal to the sine of 720. Likewise, the cosines of these values are equivalent. All right? And so therefore, in a similar fashion, right, when you're at here, you didn't even need to multiply it by 5. You just need to know that the sine of pi by 2 is 1, because it's like we're spinning around the circle 5 more times. All right? And so that's why you get the equivalent angle, which is still 1. And so 2 times 1 is 2. All right? That's 2 over 5. That's B. Easy question. Now question 43. Right? Question 43 now is it's telling us that the displacement S of a marble moving along a board at time t, where t is minutes, is given by S of t is equal to 4t cubed minus 30t squared plus 72t plus 7, for t being greater than or equal to 0. And it says for what values of t is the displacement of the marble increasing? Increasing means that the velocity is greater than 0. So that's what increasing means. Increasing means that the velocity is greater than 0. So v of t is greater than 0. So that's what we're going to have to solve. However, v is just ds. When you differentiate distance, you get velocity.
ds by dt.
So ds by dt gives us v. So in this case, ds is going to be 12x squared minus 12t squared minus 60t.
60t plus 72.
Yeah, so 12t squared plus, not plus, minus, right? Yeah, minus 60t plus 72 minus 60t plus 72 equal to 0. So not equal to 0, greater than 0. We're solving where it is greater than 0. Now, we can divide this equation by 12 to simplify it. You get 12 squared minus 5 times
t plus
6 is greater than 0.
Oh, yes. I'm just remembering now that a function is increasing when f prime of x is greater than 0.
Yes. So it's increasing when the velocity is greater than 0. All right? And so we can factorize this to be t, b, 3, 2, signs are the same, minus, minus. So that's what we have. Now look at this. When you reach this point, this is where you have to sketch the graph. When you sketch the graph,
It'll be a smile.
that'll be a smile. We have 2 and 3, 2 and 3. Or 1 when the velocity is greater than 0. So this is the line 0. Or 1 when it's greater than 0. Now the velocity is greater than 0. All over here, so, and all over here, so. All right? So the velocity is greater than 0 when the curve is above the y-axis.
Yes.
So the velocity is greater than 0 when
When the
t
curve is above the y-axis or the x-axis.
It's above the x-axis.
Ah, okay.
So when t is less than 2 and when t is greater than 3,
3.
that's when the velocity is positive.
Less than 2.
Oh, 3, not 0, 3.
Oh, so t that be between 2 and 3 then, sir.
No, t is less than 2 and t is greater than 3. If t is between 2 and 3, then velocity is going to be negative right here.
Oh, okay.
Because it's below. When it's below, it's less than 0. That's why I put this 0 right here. This signifies the line where v is equal to 0. And 1 when it's greater than 0, so it's above this line. So if I were to cut off this part of the solid, cut off down here, so don't look down at the bottom. So I'm going to completely block out the bottom. Completely block out down here. So we don't want to ignore down here, so right? We don't want nothing to do with down here, so. And so the solution is only true when t has to be less than 2 or when t is greater than 3. All right?
T less than 2 and t greater than 3.
Exactly.
So what option is that now?
That's D.
Okay.
All right. Now question 44. 2 questions to go. We have now that it says that we have
3/2.
Yeah, 3/2. We don't need to work it out. So again, to do this question.
I get sign 3/2, sir.
What?
And I sign 3/2.
Oh, 3/2. Sorry. My bad. For some reason, I only saw the 3/2. I did not see the sign. So to do this question again, only thing we had to do was notice that
Separate it, sir. Separate the numerator from the denominator. And then you multiply by 2 by 3x.
multiply by 3. So we have sine 2x over 2x. So what we can do is put a 3 in the numerator and put a 3 in the denominator. So we want the limit as x go to 0 of this. So now, because multiplication is commutative, I can then rewrite this as the limit as x go to 0 of, put back the 3 in the numerator, 3 sine 3x divided by, now I can flip the 2 and the 3, so I can put the 2 here, so, and then write times 3x. Because 2 times 3x is the same as 3 times 2x. All right?
Oh, yes, sir.
In this part, the limit is 1. And so that part, now this becomes equal to 3/2 times 1. So that's how we get 3/2. All right? So that's how we get 3/2. Easy, soft, with a capital T. All right? Now this question, it says we have water is leaking from a tank. So the water is automatically decreasing, and so the volume is decreasing. So the rate of change of volume of the tank, rate of change of volume in the tank with respect to T is inversely proportional to its volume. So let's write down the first thing that they said, the rate of change of volume. Rate of change of volume is dV by dt. So dV by dt is, they said it's inversely proportional to its volume. And remember, the volume was negative, so it's inversely proportional. So let's not even write equal to it. Let's write the proportionality sign. So it's proportional to -1/v. So that's what it's equal. That's what it's proportional to. So to write this as an equation now, it is.
Sir.
Yeah.
1 minus 1.
It's minus 1 over V. Inverse is 1 over V, and then it is negative 1 over V because the volume is decreasing. So let's look at it as this way then. It is 1 over minus V. And it is minus V.
So if it is, so
It's
if the
minus
volume is
V.
decreasing, then you put a negative sign?
Yes. The volume is
Where
decreasing, you put a negative sign. So right
water
here.
is leaking from a tank.
Yes. Leaking from a tank. So that's why you put minus V. The volume is only decreasing.
Okay.
Right? So that's why. So it's proportional to 1 over the volume. This volume, however, is decreasing. So you put 1 over minus V. And so dV by dt is equal to
Some constant
minus some constant K
K over V.
over V. K over V. Minus K over V. That's B.